Hello and welcome to the first lecture of data structure, and we'll see first chapter of data structure using C. First chapter is introduction of data structure. It is for 6 marks. We know that what is data? Data is nothing but what collection of facts or collection of information. We need data to process on it. We need to process on that data and will provide output after processing after processing that data. So we know various data types in various programming languages which are used to store that data, like integer, character, float, and others also, other data types also. And we know these data types can store data in a specified format, and it requires some memory to store them. There are two types of data types: primitive, which are user defined, which are system defined, sorry, and some are user defined. Means user can define those data types such as array, structure, queue. There are various data types. Then, now what is data structure? Data structure is nothing but it is actually a logical thing. It provides the way you can store the data. It provides the way you can store the data, and you can access that data. You can perform various operations on that data by using data structure. It provides a system. By using that system, you can store data, you can retrieve data, and you can perform various operations on the data. Means it is the way you can store the data. For example, you can say you can get the example of, suppose, messages. How messages come in your mobile phone? It is come, which message will notified first, which is the most recent one. Which is the most recent one means the message which comes last will get notified first. This is the way your messages are stored in your mobile phone. Okay, this is the way. This is the data structure which is used to store those messages. Similar various data structures are available for you, which are like stack, queue, list, trees. By means of those data structure, we can store the data. By means of those data structure, we can store the data. So you may ask, what is the use of data structure? Even though we have a database, yes, database is used to store data permanently. But before before we store the data in database, we need to process that data, no? So to process that data, we need to store them temporarily in our memory, in our computer's memory. So how we can store those data in, and how we can access those data in our memory, in our program? By using those data structure, we can we can access those data before we are going to store them in a database. Okay, so the one term you may get into read, what is that? Abstract data type. You know what is data type, but what is abstract data type? Whenever you get the word abstract, you must realize that it is a logical thing. Abstract means what? Logical thing. It is not a physical thing. So abstract data type is nothing but what? It is the way you can store the data. It is the way you can store the data so that user only knows how to retrieve data, what are the different operations available for user, and complexity means how that data is going to store, how that particular operation is going to perform. All those complexities are hidden from user. User only need to know what are the operations available for him to process that data, data how to store data. User does not need to know how that operation is going to perform. One example of abstract data type is like abstraction. It's ATM operations. You don't need to know about how that ATM operations are going to perform internally, but you need to know how to enter your PIN, how to process, how to perform various operations like withdrawal, deposit, and balance checking, whatever the rest of the operations. You need to know what are the operations you are going to perform, what is the output you may get from those operation, what is the input you need to provide for those operations. Okay, so this is the abstraction, hiding the complexity. An abstract data type means what? Data is going to store, and complexity of the data operation is hidden from users. So this is abstract data type. Now next point is types of data structure. There are two types of data structure, very important point. This question may get asked for 2 marks: linear data structure and non-linear data structure. Linear means what? Continuous memory allocation, like array. Continuous memory allocation means what? Zero, if zeroth element is stored at suppose address 100, the next element will be stored at next address. Continuous allocation. The data is going to store at in a continuous way. But and which are the linear data structure available for you, like array, queue, stack, linked list? You don't need to know, till now you don't know what is linked list, stack, and queue. You just know array. So better you just remember array. Array means what? You are storing data in a linear fashion. Linear fashion means first data, then second data, third data, fourth data. No uh, complex, no, there is no any complexity in storing the data. You just take the data and store in the next address. That is it. That is linear data structure. Then next is non-linear data structure, where data is not going to store in a linear fashion. Data is stored in a non-linear fashion, means you need to calculate what will be the next address. Depending on the logic of that data structure of that system, you need to calculate what will be the next address. Means at address 0 you will store first element. Then what will be the address of next element? How that next element is going to store? You may get idea from it. You just non-linear data structure, that is tree. Means first element is 1, then next element is 2, then 3, then 4, 5, 6, 7. If you just if you get into the this non-linear data structure, you may get knowledge of how that data, how the addresses of various data are going to retrieve or will get find. There are two types of non-linear data structure: trees and graph. Trees and graph. Okay, means just take a look at one example, like what is graph and what is tree. Suppose you need to store, values which are entered by user in a tree in such a way that left side will store the values which are less than the first element, and on the right side you are going to store values which are greater than the first element. Okay, so instead of storing those elements in a linear fashion, we need to store them in a different location. Means if you are going to use array for storing those elements, you will store in a linear fashion. No need to prepare a logic for that. But whenever you are going to store those elements in a non-linear fashion, you need to prepare a logic, you need to develop a logic, so that that particular element will be stored on that particular location, whatever the location get retrieved or derived from your logic. Okay, this is your non-linear data structure. Best example is your whenever you search any website on search engine, that search engine, whatever the searches you'll get from a search engine, that searches, all those links get retrieved from graph like data structure, graphs. Okay, and whenever you are going to store data in a hierarchical way, then tree data structure is used. Tree hierarchy, higher level, low level, like that. Then classification of a data structure, 2 marks question. Classification of a data structure. First is built in data structure, then user defined data structure. Built in data structure, actually there are data types: integer, float, character, and pointer. And user defined data types are array which is collection of similar data types, collection of elements of same data types, arrays, list, files. Then there are two types of a list: linear list, where in that there are two subtypes: stack and queue. Just remember what is stack. I'm just giving you a hint or idea about stack. in stack in stack you can store and you can retrieve data from one end. You can store and you can retrieve data from one end. You can store and retrieve data from one end. What is the best analogy? What is the best analogy to remember how that stack is going to get performed? Best example is uh, taking a bangles into the hand. Okay, bringing the bangles into the hand. Whenever you bring a bangle into your hand, there is only one end, there is only one way to what that bring the bangle in your hand. And whenever you want to remove those bangles, which bangle get removed from your hand? The bangle which you bring very earlier. Okay, the last bangle that you put into your hand, that bangle only get retrieved first. ओके, जी बांगडी तुम्ही तुमच्या हातामध्ये घालाल, फर्स्ट, सेकंड, थर्ड, फोर्थ, फिफ्थ, 5, 6, 7, 8, 9, 10, आता जेव्हा तुम्ही काढायला जाल तेव्हा ज्या बांगड्या, तेव्हा पहिली बांगडी कुठची येईल बाहेर? 10 नंबरची बांगडी. नंतर 9, 8, 7, 6, 5, 4, 3, 2 आणि 1. Is there any other way to insert or to remove? No, there is no other way. म्हणजेच काय, एक एन जेव्हा असेल तेव्हा त्याला काय आपण म्हणतो, त्या डेटा स्ट्रक्चरला काय म्हणतो? स्टॅक. आणि क्यू, क्यू म्हणजे काय? व्हॉट इज क्यू? क्यू इज नथिंग बट व्हॉट? लिनियर स्ट्रक्चर. और just take an analogy of railway engine, railway. By one compartment, by one, after one cell there is another cell, then another cell. ओके, जसं आपण रेल्वेचं बघतो की एक डब्बा गेल्यानंतर दुसरा डब्बा असतो, तिसरा डब्बा, चौथा डब्बा, बरोबर ना? आणि त्याच्यामध्ये किती असणार आहेत एंड? तर 2 एंड्स असतील. देर आर 2 एंड्स अवेलेबल फॉर क्यू. किंवा क्यू जसं आपण म्हणतो क्यू, व्हॉट इज क्यू? की जसं त्याला सर्व्हिस भेटत जाईल तसा तो त्या एंडपासून काय होईल? रिमूव्ह होईल. आणि त्या दुसऱ्या एंडपर्यंत, एंड पासून तुम्ही काय करणार? एलिमेंट्स ॲड करत जाणार. फॉर एक्झाम्पल, सिम्पल एक्झाम्पल, तिकीटची लाईन आहे सपोज. तर तिकीटची लाईन जी आहे ती तुम्ही सुरुवातीला जाऊ शकता का? नाही. ॲड व्हायचं असेल तर काय? त्या जो माणूस तुमच्या पुढे असेल त्याच्या पाठीमागे तुम्ही उभे राहत जाल, बरोबर? आणि त्याला सर्व्हिस भेटली, म्हणजे एखाद्या माणसाला तुम्हाला काढायचं असेल तर काढण्यासाठी कुठून जाणार तुम्ही? सुरुवातीपासून की शेवटपासून. सुरुवातीपासून जे आहेत, म्हणजे जो पहिला आलेला असेल माणूस त्याला पहिली सर्व्हिस भेटेल आणि तो काय होईल, निघून जाईल. त्याला पहिला तिकीट भेटेल. सो स्टॅक इज वर्क ऑन स्टॅक. स्टॅक इज वर्क ऑन लास्ट इन फर्स्ट आउट, लिफो म्हणतात. लास्ट इन फर्स्ट आउट. क्यू, क्यू इज वर्क ऑन फर्स्ट इन फर्स्ट आउट. जो पहिला येईल तोच पहिला बाहेर जाईल. फर्स्ट इन फर्स्ट आउट इज क्यू. लास्ट इन फर्स्ट आउट इज स्टॅक. नॉन लिनियर लिस्ट कोणते आहेत, तर ट्रीज अँड ग्राफ. ट्री म्हणजे काय, व्हॉट इज ट्री, तुम्ही आता बघितलं असं हायरार्की की ज्याच्यामध्ये काय असणार आहे, रूट. इन दॅट डेटा स्ट्रक्चर देर इज रूट. व्हॉट इज द डिफरन्स बिटवीन ग्राफ अँड ट्री, तर ग्राफ अँड ट्री जर तुम्ही बघितलं, व्हॉट इज ग्राफ अँड ट्री. ट्री देर इज नो सायकल, म्हणजे पुन्हा पाठीमागे फिरून तुम्ही परत रूटवरती येऊ शकत नाही. देर इज नो सायकल इन द ट्री. बट इन ग्राफ देर इज सायकल. ग्राफ, इन विच सिच्युएशन ग्राफ इज गोइंग टू ड्रॉ. सपोज तुम्हाला ड्रॉ करायचं आहे ग्राफ, की सपोज व्हॉट इज द पाथ फ्रॉम रत्नागिरी टू देवरुख. रत्नागिरी टू देवरुख. देन you need to draw a graph. From Ratnagiri there are two ways you can reach to Devruk. One way is from Ambav, Tursani, okay, Ambav, Tursani, and whatever that villages come into that path, you can reach to Devruk. And other way is from Ratnagiri to Sangmeshwar, and then Sangmeshwar to Devruk. Means you can draw various vertices and you can join those vertices by various edges. Okay, this is what your graph data structure. Okay, and tree is what, tree there is no cycle. If there is no cycle of graph, tree is actually a graph, but if there is no cycle, then it is called as a tree. What are the different operations performed on a data structure? Which operations can be performed on data structure? First is inserting a data into the data structure. Then retrieving data, retrieval of data. Then third is deleting data. If you want to delete any data, then you can delete data. Search any data, you need to search any data into the data structure. You must get value of that data by using the search operation. Then you can sort in ascending or descending order. You can sort whatever the data you got into your data structure. Then you can sort those data by using various sorting algorithms, sorting methods. Then merge. If you have two data structures available for you, and you can merge those data structure into one extra or large data structure, and you can merge those small data structure into that big data structure. This is your merging operation. Then next is algorithm. You know what is algorithm, what is flowchart. Algorithm is nothing but what, sequence of steps need to perform a operation, need to perform the task, whichever ask, जे टास्क करायचं आहे त्या टास्कसाठी ज्या तुम्ही स्टेप्स लिहाल त्यांना काय म्हणणार तुम्ही, अल्गोरिदम. व्हॉट इज फ्लो चार्ट, इट इज डायग्रामॅटिक representation of algorithm. It is diagrammatic or graphical representation of algorithm, whatever the steps. What are the different properties of algorithm? काय काय असतं algorithm? Input, output, it produces output. Then finiteness means what, there should be algorithm should be stop. Algorithm should not be infinite in nature. Algorithm should stop at some point. Definiteness means what, algorithm should not be ambiguous. Ambiguous means what, confusion. It should be clear and concise. And effectiveness means what, it should not eat so many resources. It do not require too much time to produce the output. It do not require too much memory. So all those properties, by considering all those properties, we need to develop an algorithm to solve particular problem or to solve ask problem. Hmm? There are two different approaches to design a algorithm. One way is top down approach and other is bottom up approach. What is top down approach? We need to divide the task into various subtasks, okay, and by dividing all those tasks and by solving all those subtasks, we can we can find the solution of given problem. This is what top down approach. Other is bottom up approach. What is that bottom up approach? Collection of all those sub parts or sub problems, collection of solution of all sub problems, and all those solutions are merged into a single solution. This is called bottom up approach. This is what bottom up approach. Then next point, very important point, is complexity. What is complexity? Complexity of algorithm is measured in two terms. Complexity of any algorithm is measured in two terms. One is space complexity, related to memory, how much memory is required to solve the problem, to complete the algorithm. And other is time complexity, how much time is required, how much time is required to algorithm, how much time is required to complete the algorithm. One other is time complexity. Okay, so for space complexity we need to find how much memory required by various variables, whatever the variables you declare in the program. And by calculating the sum of all the data, all sum of the size of all the data types, all the data types of all the variables, we can retrieve space complexity. For example, in this example, there is an array of data type integer, and there are of size 4, variable sum of type integer, variable n of type integer. We know that integer is having a size of 2 bytes, so array requires 8 bytes, some variable requires 2 bytes, and n variable requires 2 bytes. So what is the time, what is the space complexity here? 8 plus 2 10, 10 plus 2 12. Okay, 8 plus 2 here, you can check. 8 require for array, 2 for sum, and for 2 for total. Hmm? The next is time complexity, how much time is required. As you can see this but simple program, there is one for loop which which iterate from I equal to 0 to n minus 1, and it comes out of the loop when I equal to 1. When I equals to 1, 0 to n minus 1 means what? N times. And when it comes out of the loop when I is equal to n, that is n plus 1 time. Okay, so whatever the steps are there, whatever the steps are there, you need to write frequency count, means how many times they are going to perform, how many times, and how much time it requires to perform, how many times they are going to repeat, and how much time they require to perform. Okay, so statement printf, first statement printf, how many times it is going to perform? One time. So its frequency count is 1. And suppose computation time, it requires t1 time of t1 unit of time, so it is t1. Scanf, it requires, it perform by just one time, and it requires t2 times, then it is t2. Then for loop, how much, how many times this particular line is going to perform? I equal to 0 to n, but it comes out of the loop when I equals to n, means 0 to n, 0 to n, 1 to n means n, and 0 means what? N plus 1 time. So that frequency count is n plus 1, and it requires t3 amount of time, so t3. Okay. Then next is also scanf. All the statements which comes inside the opening and closing brackets of for loop, all the statements which comes after the for loop will get repeated or get performed n number of times. Means the loop is whatever the statements inside the loop going to perform n times, that particular loop is going to perform for how many times? N plus 1 time. So scanf statement will get executed n times. Sum equal to sum plus a of I is going to perform n times. Yes, n times. And last is printf statement. It is perform also. It is get performed by only one time. That frequency count is 1. So 1 1 n plus 1 n n 1, and computation time is t1 t2 t3 t4 t5 t6. That is some time unit. So time required to perform the algorithm is n plus 1 into t3 plus n t4 n into t4 plus n into t5 plus t1 plus t2 plus t6. So n into t3 plus t4 plus t5 plus t1 plus t2 plus t6, t1 plus t2 plus t3, and yes, and t6 also. T6 is just remain. So we assume that every operation requires just one amount of a time, one unit of a time. So n plus 1, n into, sorry, n into 1 plus 1 1 1, whatever that. Okay. So time complexity here, time complexity of the program which is written above is having time complexity as n. Time complexity is n. Okay. How it comes n, you just get idea of that, how it comes. Hmm? Because we take just we don't need to take what is that, 5n 6n 7n. No, we just take a variable. By means of that we can express the complexity. Okay, that is nothing but what? N. So for space complexity here is always expressed in terms of three notations. What are the three notations to express complexity or time complexity also? One is big O notation, which is expressed as O, big O notation. Then theta notation, theta notation, we get the symbol for theta. And other is omega notation, omega notation. And there are three cases always for any algorithm. There are three cases for any algorithm. First is best case. Best case means less amount of time, the condition when very less amount of time is required. Worst case, the condition or the case in which the algorithm requires more amount of a time, at most amount of a time. Best case means what? It requires very less amount of a time. Worst case means what? It requires at the most amount of a time. That is worst case. And average case means what? Either it requires more amount of time or less amount of time. It is average. It can be a best case or it can be a worst case. Hmm. And it is expressed in three notation: big O, theta, and omega. Big O means what? It provides you upper bound. It provides you the upper bound of running time for algorithm. Upper bound of running time of algorithm means what? It is actually upper limit. It is actually the upper limit of the time required to perform all the steps in the algorithm or to complete algorithm. It is the upper limit, means whatever the time you got to perform or to complete algorithm should be should be less than or equal to the big O of whatever the notation you whatever the amount you got. Means for above case you will express that complexity in terms of big O of n, big O of n. Okay, then next is omega notation. It express time complexity or space complexity in terms of a lower limit, means how much is the least amount of a time, how much is the least amount of a time required to perform or to complete algorithm. Big O specify what, how much is the utmost amount of a time required, how much is the most amount of a time required. And theta omega express means expressed the time which is the least amount of a time can be possible, least amount of a time can be possible to perform any algorithm. Big O express the at most or maximum limit of the time required to perform algorithm. And omega express whatever the least amount of a time, least amount of a time, what is the smallest amount of a time required to complete the algorithm. Theta notation, it is average case, average of most time and least time. Average of the both cases can be expressed in terms of a theta. Some of the complexities are expressed as big O of one, means only one amount of time, only one statement, and that per statement is performed only one time, that is big O of one. Big O of n means what, n number of times that particular statement, every statement in the algorithm that going to perform at most n number of time, at most n number of time. Big of n square, every statement in the algorithm is going to execute n square number of times. So this is how your first chapter of data structure, which are the points which we covered. First is what is data structure, what is the need of data structure, what are the types of data structure, what is the classification of data structure, in that linear and non-linear, which are most important, linear data structure and non-linear data structure, which are the different operations going to perform on a data structure, insertion, deletion, searching, sorting, and deleting, merging, which are the, what is the algorithm, what is the time complexity, what is space complexity, what are the three cases of algorithm, best case, worst case, and average case, and what are the three notations to express complexity, that is big O, omega, and theta. Big O express upper limit, omega express lower limit, and theta express that is mediator. Hmm? So this is how your first chapter of data structure. You can ask any questions about this chapter to me at any time. So these are the some questions which are asked in MSBT's previous year paper. What is algorithm? Linear data structure, non-linear data structure. What are the different operations performed on a data structure? Classification of a data structure. That are all these points, all these questions are covered in above subject material. So I hope you understood all the topic points, and if you don't, then ask me any query what you got. Hmm? Thank you very much.